Okay, so we're going to do the exact same types of problems, except now we're going to be dealing with radians, because I know we're dealing with radians because I have this interval from pi over 2 to pi. So I want to know where my sine is 1/2. So from pi over 2 to pi means that my quadrant that I'm dealing with is here in quadrant 2. Pi over 2 up top, pi over here on the left. So my angle's in quadrant 2. My sine is going to be positive. If we think about those ordered pairs, this is going to be negative. Positive sine is your y value, so that's corresponding with that positive 1/2. So what I need to do now is find what angle, or what reference angle is going to have a y value of 1/2? Well, that y value of 1/2 right here, that sine value of 1/2, corresponds with pi over 6. Okay, so I need to find what angle in quadrant 2 is going to have a reference angle of pi over 6. Well, going back and thinking about reference angle, if this is 6 pi over 6, now we chose that to be 6 pi over 6 only because I have that denominator of 6. My angle is right here, so you would have to do 180 minus your angle to get your reference angle. So I'm going to do 180, or 6 pi over 6 minus my reference angle. That's going to give me 5 pi over 6. So this is telling me that the angle 5 pi over 6 has a value, a sine value of 1/2. Okay, so we're going to make it a little bit tougher here. I have that secant of theta equals negative radical 2. Well, when we look at our chart, we don't have a secant, but what we do have is a cosine, and we know that cosine is the reciprocal of secant. So if secant is negative radical 2, then that means cosine of theta equals negative 1 over radical 2. Or after you rationalize that, you're going to get negative radical 2 over 2. So then that's what I'm looking for in my chart. What angle measure has a cosine value, an x value of negative radical 2 over 2? Well, I can see that cosine, that x value of radical 2 over 2, belongs with pi over 4. So as I sketch my angle here, and I know that it's going to be in the third quadrant, and I know that because I'm dealing with the range of pi to 3 pi over 2. So I need to figure out what angle between pi and 3 pi over 2 has a reference angle of pi over 4. Well, it's 4 pi over 4 if we think about having that common denominator of our reference angle, and then I have to have this distance of pi over 4 past 4 pi over 4. So I'm going around the circle 4 pi, and then I'm going pi over 4 more. So the way I'm going to find that is by taking 4 pi over 4 plus pi over 4 more, which means 5 pi over 4. So if I take the cosine of 5 pi over 4, that's negative radical 2 over 2, which means the secant would be negative radical 2. Now, why is it negative? Well, that goes right back to your ordered pairs, that in this quadrant we have the ordered pairs of sines negative, negative, and that cosine is your x value, which is negative, which is why my original problem is starting off negative. All right, so our last example here, tangent of my angle equals negative radical 3. So what angle has a tangent value of negative radical 3? Well, we know that the angles that have pi over 3 as a reference angle end up with a radical 3. Now, why is it negative? It's negative because we're in the quadrant from 3 pi over 2 to 2 pi, which is quadrant 4 here. So tangent's going to be negative because my sines are positive, negative, and tangent would just be sine divided by cosine, which would be a negative divided by a positive, which is going to be a negative value. So since it's in that fourth quadrant and it's tangent, it has to be negative. So now what I'm going to do is I'm going to deal with that pi over 3. So I need to find the angle that's in this quadrant that's pi over 3 away from 2 pi, essentially. That's away from that full circle. So I'm going to take 2 pi, which is 6 pi over 3, and I chose that over 3, so I have common denominators with my reference angle, and I'm going to subtract pi over 3. And that's going to tell me that the angle 5 pi over 3 has a tangent of negative radical 3. All right, guys, that's it. Make sure to check out the Give It a Try.